Guys, so I'm going to be doing it a little different for this last video. Had a little trouble with my iPad, so we're going to try doing it this way. So um, we're going to be talking a little bit about molar mass. So the mass of 1 mole of something, okay? So molar mass is the mass in grams of 1 mole of any pure substance, okay? So for example, carbon, the molar mass for 1 mole of carbon, okay, is going to equal 12 grams. The molar mass of any element is numerically equivalent to the atomic mass and has the units grams per 1 mole, okay? Now, we've also talked about Avogadro's number. So 1 mole of iron is equivalent to 6.02 times 10 to the 23rd atoms of iron. But 1 mole is also equal to the atomic mass of iron, okay? For atomic hydrogen, the molar mass is 1 gram. So 1 mole of hydrogen is equivalent to 1.0 grams of hydrogen, which is the atomic mass that you see on the periodic table. It's usually the decimal number, okay? So this figure shows 1 mole of carbon, sulfur, and iron. So a mole of carbon atoms. So if I actually mass out 12 grams of carbon, this is what 1 mole of carbon looks like. Now, 1 mole of sulfur is 32.1 grams. Notice how the volume is not going to be the same because remember, we're talking about 1 mole of a specific element. So each element is going to look a little different. Okay, so the volume of these is not going to be the same as the mass. Okay, and then this right here is 1 mole of iron. Okay, and so on and so on. Okay, now if we're looking for the molar mass of a compound, we're going to take that individual mass of each element and then we're going to add them all together. So for our purposes here, this is sulfur trioxide, meaning there's 1 sulfur with 3 oxygens attached. Okay, so 1 sulfur atom and 3 oxygen atoms. So in essence, we're going to take the atomic mass of sulfur plus 3 oxygen atoms to equal a total mass of 80.1 AMU or grams. So 1 mole of sulfur trioxide is going to equal 80.1 grams of sulfur trioxide. So when we're trying to calculate the molar mass, we're going to add up all of the atoms of each individual element together, okay? So let's try to calculate. Now, I'm using a different term, formula mass, okay? Molar mass is a general term, kind of like when we were talking about in the last video how particles can stand for many things. So for example, particles could stand for atoms, ions, molecules, or formula units. So the molar mass is the same thing as a general term like we use for particles. It can represent formula mass and molecular mass, okay? So they use the term formula mass or molecular mass. They're talking about the same thing, okay? They're talking about the molar mass of a substance. So for our purposes here, we have magnesium carbonate, which means we have 1 magnesium, 1 carbon, and 3 oxygens. So when we add this all together, we're going to look up the atomic mass of magnesium, look up the atomic mass of carbon, and look up the atomic mass of oxygen, but we have 3 of them. So we'll have to multiply that by 3. When you guys do this, I want you to go out to 2 decimal places. So when you look up the periodic table or look up the mass of these elements, I want you to round everything to 2 decimal places. So everybody's answers will be consistent, okay? So here we have magnesium. Now remember, the number above or the non-decimal number, that's going to be the atomic number. We don't use that number. We're going to use this bottom number down here, okay, for each one, the decimal number. Now, if you want to use all of them, that's fine. If you want to use 24.3050, that's fine. But I at least expect you to go out to 2 decimal places, okay? So if you don't go out to 2 decimal places, I will take off. You can go out further. You just need to at least go to 2 decimal places. So now I'm going to take 24.30 plus 12.01 plus 3 times 16.00, okay? And I'm going to get 84.30, all right? So that's going to be your answer. So thus 84.30 grams is the formula mass for magnesium carbonate. Okay? All right, so let's do another one. So molar masses of glucose, water, and paradichlorobenzene, okay, which are moth crystals. So 180 grams is the molar mass for 1 mole of glucose. For water, it's 18 grams, okay? And for moth crystals, it's 147 grams. So like there, you're gonna add everything together. So in that case, you had 6 carbons, 4 hydrogens, and 2 chlorines. So you would add everything together. Okay, so molar mass is the generic term for the mass of 1 mole of any substance expressed in grams per mole. The same as gram molecular mass or gram formula mass. So gram molecular mass is for molecules, gram formula mass is for ionic compounds, and the atomic mass for elements. Okay. So let's go ahead and calculate the molar mass of the following and tell what type it is. Okay. Oh, these are a little bit off, so I'm gonna have to fix these. So for sodium sulfide, it's 2 sodiums plus sulfur. It's gonna give you 78 grams per mole. Sorry about this. I guess when we converted from PowerPoint into Google Slides, it messed it up a little bit. Okay. Then you have N2O4. All right, that's gonna be the next one. That's going to be 92 grams per mole. So 2 nitrogen plus 4 oxygen is going to give you 92. Next is carbon. Carbon is going to be 12 grams of atomic mass. Okay. Next, now, here's where it gets tricky. When you have parentheses, it's kind of like math. You have to distribute that 2 to both elements. So in our case here, we're going to have 1 calcium, 2 nitrogens, and 6 oxygens. So when we add these together, you're going to have the atomic mass of calcium plus 2 nitrogens plus 6 oxygens. And you would end up with a formula mass of 164 grams per mole. Next, we have glucose. 6 carbons, 12 hydrogens, and 6 oxygens would equal 180 gram molecular mass. And you see how I'm changing these based on, you will not have to do that. All you have to do is write grams per mole. That's all I expect you to write, okay? And then the last one, 149 grams per mole for the gram formula mass, okay? So this is how we're gonna do molar mass. So you're gonna have an assignment the next day, and this is what you're gonna be doing in that assignment. You're gonna be adding up all of the atomic masses for each element and the quantity of each element, okay? All right, so let's try this. Find the molar mass of a compound. The decomposition of hydrogen peroxide, H2O2, provides sufficient energy to launch a rocket. What is the molar mass of hydrogen peroxide? So we have 2 hydrogens plus 2 oxygens, right? So we have 2 grams of hydrogen plus 32 oxygens equals 34. So the molar mass is 34 grams per mole. Now someone's going to go, well, wait, Miss Urshey, hydrogen has 1 mole or 1 gram. Yes, but remember, we have 2 of them. And oxygen has 16, but remember, we have 2 of them. So that's why I have 32 here. So when you add all this together, you get a combined mass of 34 grams. So the molar mass of hydrogen peroxide is 34 grams per mole. Okay? Now, that's it for today. I hope you enjoyed your lesson on molar mass. Okay? And we'll talk to you later.